Hi everyone, I'm going to teach you about PMI. PMI stands for Principle of Mathematical Induction. That PMI has two types of PMI. That one is just PMI, normal PMI, and two is a PSMI, or that means Principle of Strong Mathematician. That's stronger. Okay, that is. Okay, first that's just PMI. That's PMI used to prove something that like a PN that Pn is a on n is national number. Okay, maybe include zero in some time. Okay, that concept of PMI is so easy. In the domino, if you will prove that domino are falling of them, first we will looking for first one of domino is fall, it fell. Okay, and we will looking some domino if that piece that fell and next piece it failing too. Okay, that if those of thing is true, we can prove that our domino will fail. Okay. Okay. If you wonder how it works in the mathematics, I will show you something. Something that the axiom of mathematics that called Wolf or well ordering principle. Well ordering principle. Okay. Well ordering principle is a sentence that's so easy that call if S is a set and S is a subset in n is the natural number, okay, and S is not the empty set, then S has the minimum member. Okay, just these two easy sentence that we gonna prove the PMI with it. Okay, when we gonna prove something with the verb, we will call proving. Okay, we will one is a let S is a set that not Pn. Okay, and n. Okay, uh, later I'm talking that Pn is a on natural number, maybe equal 0, but in this case we will not uh, integrate with 0. Okay, we will looking for Pn. Later Pn that can be anything that we want to prove. Later Pn is a equation with the n variable. Okay, or that Pn or something that we gonna prove. Okay, but we're gonna let S is a not Pn, and we will use the contradiction to prove that. Okay, first we let this. Okay, now two, we will assume that S is not the empty set. Okay, and with these two conditions we will get form of S has the minimum member. Okay, set has a minimum member, we will let it k. Okay, we will let the minimum number in S is a k. Okay, the important part of this is I will let it IM1. Okay, is proving P1 is true. Okay, if we prove it with something that of the P1 is true, form P1 is true, that means not P1 is false. On the other hand, that means 1 is not in S. Yeah, I understand because S is not P1 is real, is true, but P1 is true, not P1 is false. That make P1 is not in S. Okay. Okay. If one is in S, that means k is a minimum member in S. Minus 1 is will in N. Yeah, because it's a list of k is a 2. 2 minus 1 is 1, and that is in N. Okay, that will make k minus 1 is in N or k. That can be okay. K minus 1 in N, and we know k is S and k is minimum. What that mean? That mean k minus 1 is not in S, because that so less than k. Okay, k minus 1 is less than k. Yeah, because k is a natural number that make k minus 1 is less than k. That will make k minus 1 is not k S. That we will use this information. K minus 1 is an S. That means p k minus 1 is real. Yeah, that's true. Okay, that we will use this information to prove that from p k minus 1 true. We're gonna use this information to make that pk is true. What is it when pk is true? That will make the contradiction with the k is a minimum number. Because if pk is true, k is not S, that will be k is the minimum number. Okay, that will contradiction with the verb, and we will get S. When we is contradiction, that S equal to empty set. That means not Pn is equal to empty set. That means n is equal to n. Yeah. Okay. That the thing that we gonna get it, and that's it. In this we call verb or the ordering principle. Okay. But we will use this uh this principle to make the thing that called PMI. Okay, if you looking at it, it's so long. Yeah, can you feel it? It's so long. But if you looking good, you will see the important part of this. I think, yeah, this one of important part. Okay, and I think that important part is in this. Just this is the important part. Yeah, we have just two important parts. That one important part is P1 is true, proving P1 is true, and another important part is let p k minus 1 is real and prove pk is real. Okay. Okay. If we know it two important parts, the PMI is use two important parts to make this. The concept of PMI, that's just the two parts. One part is called proving P1. But maybe in another case that P1 is not just 1, maybe it's not a 3, maybe it's not a P4, P0, maybe. But in this case, we will looking for P1. Okay. Yeah, first important part is a proof P1, and second important part is proving the pk minus 1 true from pk. That with if I talk easy, that assume pk and proving pk plus 1. Okay. Okay. Yeah, that's so easy. But if you're looking for a reason why we should to prove p1, yeah, we prove p1 that because if you're looking in the verb, that p1 is true, that's so important for k minus 1 is in n. Yeah, if we're not proving p1, we will can show that pk minus 1 is in n, that we can use the verb. Okay, that if we can use the verb, we can prove that. Yeah, that will can. Yeah, that can. Okay, from the second Okay, continue. We will looking for the true. Okay, that's this column. Okay, proving pk plus 1 is true from pk. But that mean we will use the information for pk to prove that pk plus 1 is real. 2. Yeah. I mean this 2. Okay. Yeah, it just have the two important thing. But if you want to know the reason why we use this, if you looking above or no, I mean below in the verb, you will see that thing that important is the one, let pk minus 1 is not in s. If you compare with this, that like the pk. Okay, and in this verb we will prove the pk. Okay, is true too, and if you prepare with it, it's like the pk plus 1. Okay. Yeah. In easy, PMI is a verb, but it will can be scaling of is that the verb, but it's not so long like verb. Okay. Yeah, it just have the two part of this. Okay. If you know, I will prove something for example. Okay. Example. I will make the problem like proof 1 plus 2 plus 3 plus plus n is equal to n divided by 2 times n plus 1. Okay. Okay. With the principle of mathematical induction, in the first class we will prove let Pn is a sentence called 1 plus 2 plus 3 plus n equal to uh, n divided by 2 times n plus 1. Okay. Okay. We let Pn is this sentence. Okay. Or my problem is have the problem now. I should to n is in the n. Okay. Okay. Now we get it. Okay. Okay, like this. Good. From first pass we will put p1. Uh, from from 1 is equal to 1 divided by 2 times 1 plus 1 is equal to 1. What that we get? That mean p1 is true. Okay. Yeah, that's a you look in, yes, 1 divided by 2 times 1 plus 1 is 2. 2 uh 2 divided by 2 is 1, is equal to 1 plus, yeah. From this we get that p1 is true. Okay. I think that's the first part, it is p1 is true. Okay, now we have the second part, is the proof p1 from pk. Yeah, plus 1 from pk. Okay. We will assume pk is real, is true, I mean, sorry, pk is true. What we have when pk is true, that means 1 plus 2 plus 3 plus plus k is equal to k divided by 2 could k plus 1. Okay, we get this. Okay, we have this, the equation that we can do something, do anything with this equation. If I want to get the pk my pk plus 1, I should to pass the k plus 1. Okay, plus k plus 1. I pass k plus 1 from to both of side of equation. Okay, that I can do it because I pass that to both of side. That means that same equation. Okay. Okay, I think it I just grouping. We have k and 2 plus 1. Okay, we get this as k plus 1 is 2k plus 2. What? No, it's a k plus 2 times 2. I will do it. I will k plus 1 divided by 2 times k plus 2 is equal to k plus 1 divided by 2 times by k plus 1 plus 1. Yeah, if you're looking for this form and looking for this form, okay, what you see, you will see that k plus 1, yes, k plus 1, k plus 1, k plus 1. But in this form, that's n. What that mean? That mean pk plus 1 is true. Yeah, we have two conditions. It's the two part. Yeah, if we can prove these two part, therefore PMI, we can prove that 1 plus 2 plus 3 plus plus n equal to n divided by 2 times n plus 1 for all n is in n, that will by PMI. Okay. Okay, my first case is looking good. Bye bye everyone, and I will have the episode 2 with a strong mathematician proving. Okay, bye bye.